Your duty. Every student matters.
Hello students, my name is Sanjay Jain. Welcome to the first chapter of class 9th, that is number systems. This chapter is really important from the perspective that it will go a long way with you, right? It is the foundation of the mathematics that we are going to study in this class, in higher classes and in our next graduation classes also, right? So we will pay full attention to this chapter here, number systems. Okay, so let's study about various types of numbers first. Everybody of us has seen this number line, right? There is this 0 here, and then on this side, right side of the 0, we have got positive numbers, right? And it goes up to positive infinity. And on this left hand side, we have got negative numbers, and it goes up to negative infinity, right? So out of these numbers, we can categorize various numbers like this. First is n. We denote natural numbers by n. What are natural numbers? These are just the counting numbers. For example, let us say there are trees in a jungle. So how would you count those trees? 1 tree, 2 trees, 3 trees, right? So we started our journey of mathematics with these natural numbers. So what are natural numbers? 1, 2, 3, 4, 5 and so on. Okay, when I write ... it means so on. Okay, so it will continue like this, right? So if I ask you how many natural numbers are there, you cannot count, right? Infinite number of natural numbers will be there. Okay, but which natural number is the smallest one? You can tell me the smallest natural number, which is 1. Smallest natural number. Now if I ask you what is the largest natural number, as I told you that we go up to infinity, so you will say infinity, but it is wrong, right? Infinity is not a number. Infinity is denoted by this letter here. Infinity is not a number. If you want to say it something, then we can say that infinity is just a notion, right? We can think about it, but we cannot write it on our paper, its exact value, right? So the smallest natural number is 1. What is the next natural number? It is 2. What is the next one? 3. Now if I ask you how many natural numbers are there between 2 and 5? Between 2 and 5, right? So your answer will be 2. There are 2 natural numbers between 2 and 5, and those natural numbers are 3 and 4, right? Next category of numbers. Now we started with natural numbers, then came whole numbers. Whole numbers. Now difference between natural numbers and whole numbers is that whole numbers also include 0. Apart from these natural numbers, whole numbers also include 0, right? So if I ask you what is the smallest whole number, you will say 0. What is the next whole number? You will say 1. So whole numbers include the natural numbers as well as 0. Okay. Okay. Next comes integers. Integers. These are generally denoted by letter Z. Okay. Because it is the first alphabet of a German word. Okay. But for now you should consider that we denote integers by Z, right? What are integers? Integers are these numbers which you can see right now on the number line, right? Which I have written here, -4, -3, -2, -1, 0, 1, 2, 3, 4, right? These are integers, full numbers without any fraction. So integers are of the type -3, -2, -1, 0, 1, 2, 3, 4 and so on. So integers include the whole numbers that we just discussed as well as the negative numbers also, right? and these negative numbers are not fractions, right? So this is a full number. What I mean to say is there is a gap of 1. If 0 is the integer, what is the next integer? Next positive integer is 1. You add 1 and you will get the next positive integer. To get the next positive integer, you again add 1, right? And to get the first negative integer, you subtract 1. The next negative integer, you subtract 1 again from -1. -1, -1, right? So you are subtracting 1 from 0 to get to -1. You are again subtracting 1 from -1 to achieve -2. So there is a full gap of 1 unit. Okay, this I have taken as 1 unit here. Okay, this is 1 unit. So these are negative integers. Now in integers, if I ask you what are positive integers? Positive integers are 1, 2, 3, 4 and so on, which are also natural numbers. So these are positive integers, right? If I ask you what are non-negative integers, non-negative integers. Now how are they different from positive integers? Because non-negative integers also include 0. 0 is also non-negative, right? So 0, 1, 2, 3, 4 and so on. These are non-negative integers which are also whole numbers. So another name for whole numbers is non-negative integers. Another name for natural numbers can be positive integers. Okay, and another category of integers can be non-positive integers. What are non-positive integers? Now non-positive integers will include negative integers. Let us start from -2, -1, and it will also include 0. Okay, non-positive, so they cannot be positive but they can be 0. After 0 the positive integers will start, right? After 0 there will be 1, right? 0 is neither negative nor positive. So if I want to write non-positive integers, I will write it like this, right? And then dot dot dot. These dots signify that there are numbers before it also. Okay, all right. So these are non-positive integers. And what are negative integers? Negative integers, then we will not include the 0, and these are the negative integers. So if I ask you, give me the greatest negative integer, so you will say this is the greatest negative integer. If I ask you greatest non-positive integer, you will say 0, right? So these are the integers. Now apart from these, now we have discussed these numbers that we could see on this number line. Are there any other numbers on the number line? Is there any number between 0 and 1? Okay, let us look at it. This is 0, this is 1, 2, 3 and so on, -1, -2, -3 and so on the negative side. So between 0 and 1, if I see what is the middle number of 0 and 1, if I add 0 and 1 and divide it by 2, what will I have? I'll have half, right? So in the middle of 0 and 1, just between 0 and 1, in the middle I'll have half. Okay, now look at this gap, 0 and half. If I add 0 and half and then divide it by 2, I'll get the midpoint of this gap, right, which will be 1 by 4. So this point here denotes 1 by 4, right? So what can I say out of this? I can say that there are numbers between 0 and 1 also. We need to categorize those also. Okay, so let me categorize the numbers like this: rational numbers, and then In the next lecture we will also discuss about irrational numbers, but I'll give you the introduction in this lecture also. Right? Rational numbers and irrational numbers. So the numbers of this kind which can be written in the form of p by q, okay, where q is not equal to 0, because denominator cannot be equal to 0, right? Then this number will not be defined, okay. So q cannot be 0. The numbers that can be written in the form of p by q, where q is not equal to 0, are known as rational number, okay. Another thing that we can say about these numbers, rational numbers, the first thing that we said is that they can be written in p by q form where q is not equal to 0. What is p and q? These are the integers, right? So p and q are integers where q is not equal to 0. So if I can write a number like this, 1 by 2, okay, this is a p by q form where denominator is non-zero, right? So this is a rational number, okay. I can write this number as 2 by 4 also. 2 by 4 and 1 by 2 are equivalent ratios, right? 3 by 6 for that matter is also equivalent to this. So there are infinite ways of writing this number, but if I consider that p and q are co-prime, p and q are co-prime. What are co-prime numbers? Co-prime numbers are those which do not have any common factor apart from 1. For example, if I write 2 by 3, 2 and 3 do not have any common factor apart from 1, okay. And these two numbers necessarily may not be prime, right? Why? Because I can have numbers like this, 5 by 6. 6 is not a prime, but 5 and 6 are co-prime because they do not have a common factor apart from 1. So when I write p by q in such a fashion that p and q are co-prime, then that will be the representation, simplest representation you can say, or that will be the representation that we will consider here, okay. So this is the simplest representation here. So this is about rational numbers. And other thing about rational numbers is that these numbers are terminating. What do I mean? If I convert them into decimals, or if I take decimal expansion of these numbers will have terminating decimal expansion. Otherwise, if they are non-terminating, they will start repeating, non-terminating repeating. Either they will terminate, or if they do not terminate, they will start repeating or recurring. These words can be used interchangeably in this chapter. What do I mean by terminating decimal expansion? For example, 0.5 or 0.35 or 0.571. These are terminating type of decimal expansion. What is non-terminating repeating? 0.3333 and then I write dot dot dot. So it keeps on repeating. How do we represent these numbers? We just put a bar on the part which is repeating. So which part is repeating? 3 is getting repeated, right? So we put a bar on it. This means 0.33333. So this is about rational numbers. We will study about irrational numbers in the next lecture in detail, but right now I am giving you the idea about these. Irrational numbers are the numbers which cannot be written in p by q form, okay, where q is 0. Q is non-zero, right? So these numbers cannot be written in p by q form, and q obviously is not 0, right? What kind of numbers are these? If you look at the properties of these numbers or the decimal expansion of this number, these are non-terminating, non-repeating type. Sometimes I tell my students that these are irrational, they do not follow any pattern, right? Why? Because 0.110, 1111000, they may have any pattern, right? You cannot decide the pattern and put a bar on it, right? If you see a pattern in number like this number, even if it is repeating after 6 digits, you can still put a bar here. You can represent this number 0.142857 by putting a bar here, okay, because it is getting repeated after 6 digits, okay, but it is getting repeated. There is a certain pattern. So this number is a rational number, it follows a pattern, but this number is an irrational number. And examples of these kind of numbers are root 2, root 3, and then pi, etc., right? These are irrational numbers. Now if I ask you, between 0 and 1, how many rational numbers are there? How many rational numbers are there between 0 and 1? Now look at the number line once again. Between 0 and 1, if I get to the midpoint of it, I'll get a half, right? I'll get half. If I see the midpoint of this, between 0 and half, I reach at 1 by 4. Then I can find the midpoint of 0 and 1 by 4, right? I'll get another number. You can keep on going like this, right? You can keep on finding the midpoints, and there will be infinite such numbers. So between any two rational numbers, you will have infinite number of rational numbers. What I mean to say is, between any two numbers, for that matter, in this example I just illustrated that between 0 and 1 we had infinite number of rational numbers. But if you observe carefully, between 0 and 1 by 2, again we will have infinite numbers which are rational, right? Or for that matter, between 0 and 1 by 4, we will again have infinite number of rational numbers, because you can keep on reducing that number, right? You can keep on taking averages of those numbers and finding the midpoints. This is one of the ways of thinking about it. Otherwise, how you can think about it is, now if I ask you, let us first of all think about irrational numbers, then I'll ask you that question which is in my mind right now. How many irrational numbers are there between 0 and 1? Between 0 and 1, you can have, let us say this is 0 and this is 1, okay? Between 0 and 1, you may have a number here which is 0. Let us say 2, 3, 2, 3, 3, 3, 5, 5, 5, 7, 5, 5, and keep on going without any pattern. So there may be an irrational number here, there may be an irrational number after this. So there will be infinite number of irrational numbers also between 0 and 1. Okay, so you get this point. There are infinite number of irrational numbers between any two numbers, and there are infinite number of rational numbers between any two given numbers on this number line. Now if I combine these numbers, rational and irrational numbers, that will give me the complete number line. Every point on this number line will either be rational or irrational, right? Then where are these numbers? Whole numbers, natural numbers, integers that we talked about. Look at these. 2, is it a rational or irrational? It is a rational number, because it can be written in this form, 2 by 1, p by q form, where q is non-zero. So it is a rational number. Minus 1, is it a rational or irrational? You can always write minus 1 like this, minus 2 like this, right? So these are also rational numbers. What about 0? You can write 0 as 0 by 5, right? So p by q form, where q is not 0. Denominator should not be 0. Numerator may or may not be 0. Numerator may be 0, right? Even if it is not 0, we are okay. But denominator cannot be 0. So in this case, this is also irrational number. Between 0 and minus 1 you will have minus 1 by 2, which is a rational number. Okay. Between 1 and 2 you will have a number 1.414, then it will keep on going without any repetition, right, which is also known as root 2. Okay, this is the approximate value here. We cannot calculate the exact value of an irrational number because it will keep on going without any pattern. Okay, every year mathematicians keep on finding another digit after it. Let us say they have found 50 digits, so in the next year they may find one or two more digits, but they cannot predict the exact value. Till now they have not predicted the exact value of root 2, root 3, because it is in the definition of this number that this is an irrational number. Okay, all right. So rational and irrational combined will give me the real numbers. These numbers are known as real numbers, and this number line is known as real number line. Okay, when I put this arrow on both sides, I mean this extends up to positive infinity and negative infinity. Positive infinity and negative infinity are not real. Okay, these are just the notions. Okay, I hope these questions are clear to you. Now let me ask you a question here. If I ask you, give me the number just greater than 1. Give me the number just greater than 1. So between 1 and 2 we know that there are infinite numbers. Okay, and I explained it to you that between 0 and 1 by 2 again we will have infinite numbers. So based on this concept I am asking this question, give me a number just greater than 1. Which number will it be? Some of the students may think greater than 1 will be 2. No, I am not talking about integers here. I am talking about real numbers. Okay, because these all are real numbers. Whichever number you find on the real number line, every point on the real number line will give you a real number. Okay, and every real number can be found on the number line. All right, so I am asking a number just greater than 1. Some of the students will give me an answer 1.01. Okay, but it is not the number just greater than 1, because then 1.001, right? Some other student might say this, some other can say 0.0000001, but that is also not correct, because I will put another 0, then that number is closer to 1. Okay, so do you see the pattern here? You can go on putting these zeros, but you will still not reach the just greater than number, because we have got infinite numbers between that gap also. Okay, any number you say, I will tell you, if you say this number is greater, 1 and 1.01, between these two numbers I will find another infinite numbers. So this is the beauty of this number line. Okay, so what is the answer? Just greater than 1 does not exist. So there is no number which is just greater than 1. And similarly, you can say a number just lesser than 2 doesn't exist. Okay.